All right, good afternoon, everyone. If you're not here to listen to a talk about Papyrus for real time, you're in the wrong place. If you are, thank you very much for coming. Okay, so let's get started. My name is Charles Rivet. I'm a senior product manager with a company called Xylicsoft, and we're working on parts of Papyrus for real time. First thing I want to say is, hooray, we're a real project at Eclipse since April 8th, so we have a birthday. We're all happy about that. So what is Papyrus-rt or Papyrus for real time? The real project name is Papyrus for real time. Everybody says Papyrus-rt. Well, it's a modeling environment. It's a modeling environment that is really targeted towards complex, software-intensive, cyber-physical system. So we're really augmenting Papyrus and building on that. It is based on Eclipse, and it is based on Papyrus, ergo the name. It is targeted to be industrial grade, so that large enterprises will be able to use that with everything that it entails. It is also intended to be complete, and by complete meaning that there is an ecosystem out there of suppliers that will allow us to build on top of that. So it's not just the modeling tool, but also all the integrations that go with it. So compare, merge, and Git integration and all that makes the whole tool complete to be used in an industrial environment. A lot of that comes from PolarSys. Who knows about PolarSys? So there's quite a lot, so I won't have to explain all of that. So Papyrus-rt is one of the solutions within PolarSys, and Xylicsoft company I work with, we are a member of PolarSys. And it is also made better by the brand new industrial consortium. Anybody knows about the industry consortium? There was an announcement at one of the keynote. Anybody wants to join? Just look at it, it's great. And that's what is Papyrus for real time. So we do have our own little icon too. What else is it? I already mentioned it's based on Papyrus, and Papyrus got a lot of things. Papyrus is a complete UML modeling tools, and it's got stuff, of course, like UML 2.5, but it also has things like SysML, and it's got things like MARTE and RobotML and a whole bunch of other things, which may or may not be of interest. Now, these things are there. So if you have Papyrus for real time, you can go and use those, but really what we're more concentrating upon is basing our tool on UML, to which we're adding support for UML-rt. UML-rt is a methodology that has a long background. It started up as Room, and then it morphed into other tools like, well, Room was implemented by Object Time Developer, and there's also a Room implementation in eTrice, another Eclipse project. And then it morphed into ROSE Real-Time and RSA Real-Time Edition. What our contribution consists of is a DSML, so a domain-specific model language built on top of UML, that is going to provide the added semantics of UML-rt into Papyrus. The DSML is also going to end up restricting UML to what you need just to develop those complex systems. So things that we don't really use, activity diagrams, you're not going to see by default. They are still there. We're still based on Papyrus, and if you want to use them, you'll be able to. It's just that by default, they're going to be hidden. We have a code generator, and that's a complete model code generator, so everything in the model is going to be generated to code that you can compile and run. You don't have to go and edit the code afterwards. And it does have a runtime. In order to support things like threading, dynamic behavior, dynamic incarnation of elements, timers, things like that, we do need a runtime that abstracts out the underlying platform. By default, we will be targeting Linux, but if you wanted to go on an RTOS or on Windows or anything else, you can actually modify that runtime for these platforms. One of the things that is meant to be is unifying. And by unifying, I mean that we want to look not only at UML-rt, but also provide the basis for other methodology, traditional methodologies that did real-time development to go in there. RTUML, which is what Rhapsody implements, IBM Rational Rhapsody, as well like XTUML. XTUML is the old Schlemmer work that has been created by a few companies. There's really only one left, and that's Bridgepoint. And Bridgepoint was spun off from Mentor Graphics into another company called OneFact. Now, OneFact has put all of their stuff in open source. And we've been talking a lot with the OneFact folks to see how we can actually merge all of that and work together in the context of Papyrus-rt/OneFact. Of course, they want to keep their brand name because there's equity there. But they are involved in this whole thing. And yes, we're very young, we're still in incubation, but eventually we'll come out of our shell and liven up everyone. Who is Papyrus-rt? And there's actually more than the people that are there that are starting to trickle in. But the first group of people were the CEA. Of course, they actually created Papyrus in the first place. Ericsson was there, putting in a whole bunch of requirements. They contributed a C++ profile for UML-RT. They worked on the intermediate representation. I'm going to get to the intermediate representation when I talk about the architecture. And they also provide a lot of testing of what we're doing. There's Inquiry that worked on the intermediate representation. I don't know if somebody for Inquiry was supposed to show up, but I don't see them in the room. But there's Melina Software. Melina Software is really one person, Brand Selleck, who was the brain behind Room. And he's the one who actually created our profile, the UML-RT profile. And there's Eluxsoft, my company. And we do the code generation, the runtime, and as well we end up doing the CDT integration. So we do have one person for All4Tech that's working on this. And there's the eTrice people who are actually very much interested in what we're doing, and we're starting collaboration between our projects. So the group is growing. Some history, well, it started really early, mid-2014, where we had some meetings together and we hashed out some requirements. That ended up being a project. And the project was approved, which is why I'm here today. But we quickly followed up by our initial contribution. We contributed at 0.5 because we already had a year of work and we already had releases internally before that. And then we've released 0.7 and 0.72 within a month of each other. Next release is 0.8 in early December. And one of the big things that we're going to have in there is a much better CDT integration. So remember, this is incremental, so we don't have all the functionality right from the start. But we're going to be doing a lot of the CDT stuff and a lot of the UI stuff. So please bear with me when I get to the demo. Not everything is working exactly as we would hope. And then in January, we're going to do the big jump and get onto Neon. And hopefully end up with a release on Neon in June. Again, the important part is that the bottom right project plans are subject to change at any notice. Okay, the architecture. Two parts really. There's the old, we're based on Papyrus, so we do have all of Papyrus in there. And we're providing the DSML. I already talked a bit about the DSML, so that's the whole user experience that is closer to the UML-RT paradigm than the big UML paradigm. So we have things like structure, everything in UML-RT, the structure is always through what we call capsules, which are basically composite structures. We all the communication between capsule is done through protocols. So ports that are typed with protocols, protocol deciding what a capsule can receive and send. And we have all the customization around that for the toolboxes, the model explorer, and so forth, in order to have something that really represents more a UML-RT model than a basic UML model. And of course, validation, because we are adding a bunch of rules. We are adding things on top of that that says, well, if you bind two ports together, they have to be compatible, else we're not going to let you bind them. One other thing that we have to do is actually migrate from previous tools. So we have the migration from RSA Real-Time Edition into Papyrus for real-time that's being done. There's the code generation, which is what Eluxsoft is doing. So it is, I'm going to talk about the architecture a bit later, but it's actually an incremental code generator. So you don't have to regenerate everything. It's also multi-step, so we can actually think of it as, for those who remember MDA, it's basically an MDA chain of platform-independent, platform-specific transformations. And we have a runtime service library, which is in C++. It is designed from the get-go, just like the transformation, the code generation, they are designed from the get-go with extensibility, and possibly replacement of those. So you can, because this is open source, you have access to all the cores, but we're also providing information as to how you can go and modify the code generator and how you can go and modify the runtime. And of course, compatibility, because we're migrating models, where our intent is to migrate models from RSART into Papyrus for real time, we need to have a compatibility layer for the API that already exists in RSART. If there are questions, don't hesitate, right? The architecture of the code generation. I did mention already multiple steps in the code generation. One of the things that's fairly interesting is the middle. We have a meta model here in the middle. So we're taking the pure UML code with profiles applied and then changing that into a pure UML-rt representation. So we're getting rid of a whole bunch of things and reducing the meta model, the model that we're going to work on, to the concepts that are defined as part of UML-rt. Once we have that, then we can go to a C++ model in order to generate the C++ code. But this architecture also allows us that if we wanted to support another language than C++, we could have another transformation in parallel that would be a Java implementation model and a Java transformation to Java, or System C System C platform representation transformation to C++ or any other language. So that's one way that we actually can create our code generator in a very extensible way. Initially, this is already all written either in Extend or where Extend was not able to exactly do what we wanted in pure Java. It supports incremental migration, like I said. Our first target was C++ 03 on Linux. It's been tested on Linux 10 and Linux 14. We typically use Ubuntu for the testing. And this is what the architecture of the code generator looks like. I know there's a lot of stuff there, but there's a basic generator, and then there's basically classes to handle all the different aspects of UML-rt. And these are called as needed by the generate on top. Again, extensibility. If you want to change the way the capsule is done, you can go and override this little part, and it'll do something different for you. We also have an architecture of the runtime, and I thought because this is C++, it's just easier to show the tree. So the RTS is all these files. It actually fits on one slide, which is nice. So we have build tools, and build tools simply define your tool chain. What compiler you're going to use, versions of compilers. So you can easily create more of these as it is. Those are the ones that we're shipping by default. On my machine, I actually have GCC 484 installed because that's what came with Linux, the Ubuntu 10.4. We have OS-specific fragment file because depending on OS, the delimiters for folders and things like that are all going to be different. So we do customization that way. If you add another operating system to add to that, we could actually just handle it through that. The include here is for all the API functionality, what the users of the tool are going to see, what is exposed to the developers when they actually develop a model in UML-rt. The object is where the object and library files are stored when the RTS is compiled. We then have OS-specific files for things like thread, mutexes, access to timing information, these kinds of things. So we absolutely abstract out of these, and we rely on these files to provide the actual implementation. And then we have all the source code for the UML-rt runtime itself, as well as some low-level debugging, logging for debugging that is part of the runtime. And now for the most dangerous part of any presentation, demo. Thank you. Everybody gets that one right. And now I have to sit down. I'm sorry. They should have stand one. OK. So demo, I'm going to switch to classes. So show of hand. You want to see the simple model or the large model, the complex? Simple first? Yeah, the simple is very easy. Everybody know what a ping pong game is? Yeah, okay. Because if you don't, I've got a problem.
Oh, there's a table upstairs.
That's true, there's a table upstairs. Now I'm running a virtual machine on top of my Mac, and I need a better Mac with a lot more memory.
And better resolution.
I got better resolution. The projector needs better resolution, or the capture. Okay, so I've got ping pong loaded, and ping pong is just a very simple ping pong game. So I'm going to open up top here. So you'll see that those are all the capsules, and I've got a protocol here, and protocol is just a set of in and out signals. Typically, protocols are defined from a client's perspective, because you typically have one server, multiple clients, so you only have to conjugate protocols once. I'm going to have to do a lot of these switching views. Okay, so, oh boy. I'm going to have to rearrange my diagram. So ping pong, oh, there's a zoom somewhere, right? So Rémi may tell me where I can find the zoom.
The zoom is on the right on the palette. You have a mouse side on the palette, just under.
Further down, further down, further down.
The actual tool palette. Yeah.
On the oh, there it is, yeah.
Zoom in there, and zoom out is just the other one.
Zoom.
And then minus one left and down.
Yeah.
Got it.
And you just click on the diagram.
Well, I'm clicking on it and it's not doing much.
On the diagram, you have to click on the diagram.
Okay, we're getting there. I'm usually a lot bigger resolution. So and that's, well, I think they have the same problem everywhere. So yeah, the more complex ones get a lot more capsule parts. So this is basically, there's a pinger, there's a ponger. And I wish I had navigation on this one, but and if I look at the state machines for these, got a state machine again, which is it only has, oops, well. So it's a very simple state machine where there's an entry action here. There it is. Thank you. So it's got an opaque behavior to describe what it's going to do. And that opaque behavior is, in this case, expressed in C++. Eventually, you can support other languages, but right now we're just supporting C++. And right now, the only thing it does is it logs a message. Okay, so Ponger is not quite as interesting. I'm going to close that, and I'm going to get back to, and if I look, actually I should probably just go back to Pinger, which is way more interesting. See, I did say that this was the most dangerous part of a presentation, right?
What are these three dots mean? The action.
Sorry.
Slash action. Here. In the default state, default transition.
Oh, it just means that there's more text there that's not shown. But if I look at the default transition, ah. Am I having fun? No. Okay, so I've got an opaque behavior, and this one actually has, I'm actually sending a message. So my port is called play, and from the play I send a ping message through the port. And whatever the port is connected to is going to receive that message. Now the runtime actually deals with all of that. It'll take care of sending the message, putting in the queue on the other side, because this is all queued message. And then when Ponger receives the message, it's going to basically get the next message into the state machine, process it, then go get the next machine and the next message, and so forth.
And how is modeled the different algorithm for dealing with messaging?
It's first in, first out.
Okay.
They're first in, first out queues with priorities.
Okay.
Okay, so you can actually send a message at a very low priority, in which case it's going to go to the low priority, or a very high, then it goes into a high priority queue. And basically the RTS the runtime system goes, give me the next message in the highest priority queue that's got messages. So it's going to go in the highest priority, then next, 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 and it's going to send the message. And it's going to basically empty a queue of the high priority messages before it goes to the next lower priority.
And you can configure the priorities, the algorithm, and the maximum number of messages
So,
in each queue, for example?
by default, the queues will grow. Okay, you can, there's actually internal commands where you can flush a queue, but by default, the queues are going to grow. So you'd better process your messages at some point. But it is multi-threaded, so you can actually have cross-thread messages. So you can actually assign capsules to different threads. Okay. If that behavior is not to your satisfaction, you have access to all the source code. Yes?
So is the threading model configuratable? Because I guess sometimes you need like behavior that is always the same, and if you have like multiple threads sending messages to each other, you probably don't always have guaranteed response times, which is I guess sometimes important when doing real time.
Yeah, for hard real time, yes it is.
Yeah.
So yes, the threading model is configurable. The way that capsules are allocated to threads is configurable. And it can be done either, right now it's done through a text file, because we don't have the whole configuration done yet in the tool. But eventually you'll be able to use the tool to define the configuration, which threads, which capsules to assign to which threads, and all that stuff. But right now it's just a text file where you just put the name of the element in the model, the fully qualified name of the element in the model, and then a name of a thread. And the RTS will just create the threads for each different name and assign the capsules to those threads. You can also do that dynamically. So there is such a thing as a dynamic, an optional capsule part, in which case you are responsible to select which capsule instance you want to instantiate and assigning a thread to it if you want.
And you will multi-part messages?
Sorry?
Can you deal with multi-part messages?
So a single message that you break down in multiple messages? Not directly, no. So you'd actually have you actually need to have something that breaks it up and reconstructs it on the other side. We do support multi-parameter messages, so you can have more than one parameter, one piece of information in a message, which is different from previous incarnation, which was only one message, one piece of data per message. But yeah, so you can't really decide suddenly that you're going to put a USB protocol directly on one of these ports. Typically that connects to hardware anyway, so you'd have to have an interface to hardware in order to be able to do that. But that's not, right now, if you have multi-part, you have to actually break it down on one side and reconstruct it on the other side. Okay. Yes?
Are there any task configurations such as phase, frequency, periods, with Papyrus real time?
Sorry,
Are there any task configurations? For example, threading and so on?
well, threading I already talked about. but that's pretty much it. You have to determine what your threading model is. We don't have, again, we don't have the configuration for threading models. But we have, is that what you're...
At this point, right? Because the intent is to be able to deploy on multi-core and so on.
Yes, yes. No, absolutely. So yeah, the runtime is created thinking of multi-core, multi-processor kind of thing. So that's certainly handled. So you can have multiple processes, but then you have to handle, of course, the cross-process communication. You have multi-thread, where one of the requirements is to be able to handle multi-core. So does that answer your question, or am I? Okay. Yeah. Yes.
Maybe one question in addition, talking about more also in the same direction. So is it possible also to specify, for example, deadlines or what else, or timing behavior of your systems? Because if you're modeling it, at some place you need also to configure stuff like this, not only for the scheduling or what else, but also the timing behavior.
Well, there's two things here. We do have timers in there, so you can have timeouts on certain operations if they take too long. If you want to actually validate the model against specification of response time, then we don't have that directly in the tool. We also don't have generation of that in the tool. However, because we're based on Papyrus, I have tried it. You can actually go and apply the MARTE profile on top of that, and then go and add those specifications in there. But right now, we're not doing anything with those specifications. They're more for your documentation. If this is of importance to you, you can actually use the MARTE annotations, and then go and modify the code generator in order to be able to put the restrictions directly in there.
So one thing I'd like to add is that the whole idea of the project, I mean, those are a very good point. The whole idea of the project, it's a truly open source project, and that's one of the key reasons why we wanted to get out from the commercial proprietary stuff, is that these things that have been talked about for 20 years, right, have never made it to the tool. Now we will have the base to be able to do that. And this is really where we're looking at people to say, you know, like Johan was asking about schedulability analysis and model checking and all of these things. I mean, this is the platform that we can now use all together to extend and to like the stuff that MLT is doing. I mean, that's clear, right? This is where this should have been doing for 20 years. Right, so that's really the intent.
Any other questions? Well, I don't know if I've got time to actually run this, but I can show. So now if I wanted to actually generate the code, I can just right-click on this. And run the code generator. It took 361 milliseconds to do this. And now I'm going to go to, not this one, the other one. This one. So that's the code that was generated. No, that's not it, sorry. That's the code that was just generated. I can just make it and run it.
Which is the performance that you have achieved? I mean, because in real time, for example, the project that I work with is we have a dependency that we have to work up to nanoseconds.
Okay.
So which is the precision that
Right.
performance that you have for each?
I understand. So we haven't run any metrics thus far. We're still developing. We're still fairly at the beginning of this project. So we haven't run any metrics on what kind of resolution we've got. But yeah, this is something that we do intend to do.
And I talked to Simon on Friday, I think, and there should be some fairly soon. There might even have some initial next week. So he was trying to run some metrics and compare.
Yeah. We do have metrics for the code generator, which is why we actually put up the time. But the runtime, we haven't quite done it yet.
One more question. So basically the code is executed. So I assume you simply configure the libraries that you have in the APIs at some point, and then you just hack in the text, in this case log messages, and it's just integrating
Yeah, so if I go back here, this is actually the RTS. That's the code for the RTS. And I do have a log service, a log protocol, and there's a log service somewhere else.
So the text box in the Papyrus tool, that's just plain text, right? So
At this point, it's just plain text. In 0.8, the next release, we're going to have the CDT integration. So you'll have code completion and everything.
very nice.
Okay. Any other question? Okay, so let me get back.